supporting innovative parameter smart contract. Okay, enabling it's mean that the PFH technology is enabling to encrypt the smart contract computation, uh, like mentioned before, without any, exposing the data, without exposing the data on it. So, with TFH EVM, sensitive data is stored on chain in encrypted form and remains encrypted throughout computation. Okay, it's still completely encrypted, eliminating the exposure of the plain text content. It's eliminating the exposures. Okay, this design not only enhance privacy and security, but also mitigate risk of data interceptions of tampering, simplifying user interaction. Is very interesting. The design of the mechanism of this blockchain not only enhance the privacy, okay, and security, but also mitigate the risk of the data interception, tampering, simplify user interaction. It's really interesting. Again, although TFH EVM presents challenges such as data inflation and high hardware resource demand, okay, InitVerse addressed this issue with dynamic proof of work protocol and the parallel block generation. This technology optimizes resource utilization, reduces reward strain, and improve the execution efficiency and encrypted smart contract. The introductions of the TFH EVM promotes highly privacy smart contract while achieving a balance between performance, security, decentralization, supporting diverse application scenario, and advancing the Web3 ecosystem. Yes, we know that the FH presents challenges such as data inflation. I mean, like the data inflation rate is one of the challenges that they face. High hardware research in demand. But Initial has a solution of it. They address the issue with dynamic proof of work protocol. I mean, proof of work protocol, which is everyone or everyone can do proof of work, and also using the parallel block generation. This technology optimizes resource utilization, and it means they optimize every usage of the research technology, reduce hardware strain, and improve the execution efficiency of the smart contract. It's a very interesting again. So, for next thing is dual dynamic adjustment (DDA), the core of the global block production framework. Dual dynamic adjustment (DDA), dual dynamic adjustment. So what does it mean? I assume the adjustment of this thing is the privacy and also uh, you know like transparency and privacy. They just in both of them. PFHAVM enhance data privacy but improve high computational demands on hardware. Okay, it means TFH enhance data privacy but impose high computational demands on hardware. Okay, encrypted chip per tax in TFHA is significantly larger in the plain text with the inflation factor. Depending on the parameters, security level, and data size, after multiple computation and the noise processing, cheaper tax inflation can reach up to 6,000, 16,000. or more significantly increasing storage and transmission costs. Okay, the FH operations rely heavily on Boolean algebra, polynomial computation, and fast Fourier transform (FFT), scaling hardware requirements. General hardware struggles to compete with the specialized devices like FPGA or ASIC in the high privacy and demand block, further exacerbating computational inequities. Okay, I'm really confused with this thing. Maybe we ask you now. Okay, okay, that's a very clear summary of the trade-off. I mean, we get this point. It's been the trade-off, the very advanced technology here. The trade-off using TFH EVM is the easy explanation. Okay, the price of the perfect privacy. It means the price that we have to pay, or the price that the developer or any chain face, is about think of the TFH as putting a heavy, complex suit on of armor. Okay, complex heavy armor, and then on your data. All right, that armor keeps your data perfectly safe. Yes, got it. But it makes everything much harder and slower to move. Yeah, that's true. First, solution data blocks. It means the size of the problem. Okay, this is the what they face. I mean, like the problem faced by the challenge that the Initian face. Data blocks the size of the problem. The problem when you encrypt a small piece of the data, like number 5, example, okay, encrypted small data, the resulting ciphertext, okay, become enormously larger. Alright. It's like taking a tiny single marble and encrypting it into massive box full of 1,000 random looking numbers. Got it, got it. The scale, your summary notes that after many calculations, this box can be 16,000 times or more as size the original marble. Okay. The impact storage costs. You need a huge hard drive just to hold a small amount of encrypted information. Transmission costs. Sending this massive box across the internet takes a very long time and uses a lot of bandwidth. Okay, this is a it's been they explain the type of the problem or challenge that they face. Computational strain, they have problem. Doing a simple calculations and an encrypted data is no longer simple. It's like trying to do simple addition, but you have to first perform thousands of the complex steps. The advanced polynomial math and supervised transformation just that encrypted result. The impact the massive performance requires strong hardware. Okay. The operation also demanding the dynamic for the computer chip to run efficiently. The hardware divide, the fairness problem. The problem normal computer like CPU and GPU and laptop struggle with the specific math of TFH need. Alright? To do the work fast, you often need special hardware like ASIC application specific integrated circuit, okay, FPFTA. The impact is create an unfair situations. Only people of with the money but the expenses special hardware. Okay, and this is blah, blah, blah. Okay, I got this. By this point, I mean, this is the problem that any change face as a challenging things. But of course, I do believe they have the solution. So this is the to address this challenge. I mean, to address all of the Jet's challenge, you need first design a dual dynamic adjustment. Dual dynamic adjustment, okay. Dual dynamic and DDA mechanism as the core framework for block production. As one of the core framework for the block production, this mechanism dynamically adjusts block difficulty and computational results based on the network computational power and the privacy demand, balancing privacy, efficiency, and decentralization. Okay, by the problems that are challenge they faced previously that we asked to Gemini, there are a bunch of solution on it. It's a very interesting. Yes, the mechanism that they solve or the mechanism that they are trying to provide is using DDA, dual dynamic adjustment mechanism, from the framework for the blockchain productions. It's mean by managing the blockchain production, they solve it. The mechanism dynamically adjusts. They can adjust block difficulty and computational results based on the network computational power. So it's mean the mechanism they can classify. They can classify which one is a difficult block or which one is easy one. Okay, interesting. Block are categorized into two types. It means they put the categorize high privacy block and standard block. Okay, they can so intelligently classify the data and they bring the classifications type of the high privacy block and standard block. High privacy blocks handle TFH encrypted data with the increased computational threshold to ensure data security during on-chain processing. Standard blocks with lower computational requirement allow participation from more general hardware, GPU or CPU and GPU, lowering entry barriers and promoting fairness and decentralization. Okay, that's cool. That's mean the solutions are of the things that they face, the challenge from the problem they solve because because the privacy they face they using DDA, dual dynamic adjustment to process and categorize, which is where in the important thing, where which one is less important thing. So they can maximum using of the device like use a maximum device like a ASIC, and also they can use also low demand data using like GPU or CPU computation process. It's a very interesting just because the blockchain, uh, yeah, I can say that the blockchain has its own intelligence to classify the data and processing it based on, based on needs. Like, is a very, very high demand. privacy data, and so low, this one is low demand. It means the blockchain itself has own intelligence to classify it and processing it. That's really, really cool. It's very important for RWA, I think. So, computational recommend allowing participant more general hardware, okay, lowering entry barriers and promoting fairness and decentralization. Interesting. To mitigate the potential delay caused by high privacy block, okay, when they're processing high privacy blocks, just because the example bunch of transaction or bunch of block time creation based on a block time creation to solve it to mitigate the potential delay because of the high privacy blocks. InitChain employs parallel block generation to enhance network fluidity. This technology allows multiple blocks to be generated simultaneously, or that means they can create a block or technology with simultaneously. I mean, it's going to any change use the parallel block generation to enhance network the fluidity. I mean, it's in flexibility. I think this is about the flexibility to create more block to this one. This technology allow multiple blocks to be generated simultaneously. Okay, for example, while high privacy block require additional computation time, standard block can be processed concurrently, preventing network bottleneck. Parallel block generation include multi-head integration mechanism to ensure consistency during block validation and merging. Through DDA mechanism, any chain resolve conflict between privacy demand and computational power distribution, maintaining network stability, efficiency, while meeting high-frequency data processing needed. This provides a robust foundation for smooth blockchain operation. Okay, this is the all of this address is for answering the challenge they face in any chain. So of course, I would like to ask to Gemini to make it simple to us as non-technical guy. Do the same easily. Ah, you have provided the perfect descriptions on how any chain attempts to solve the big challenge of the average slow speed and high rate cost using dual dynamic adjustment. So here's the easy non-technical works. Any chain solution, the dual dynamic adjustment DDA. The DDA mechanism is like a smart traffic controller for the blockchain. Okay, DDA mechanism is like smart traffic controller for the blockchain. Its job to keep the network fast, fair, and private all at once. Even with when dealing with the heavy encrypted data. Okay, splitting the work to type block instead of treating all data the same. Any chain separate block into two lines. Ah, okay. This grade they divide into two types. High privacy block, standard block. The job handle the TFH, the heavy complex calculation. Then hardware they needed requires specialized powerful hardware. Okay. Goal guarantee security for the private data but takes longer. Standard block handle regular simple transaction, lower computation need, can use general hardware, standard GPU and GPU. ensure fairness and decentralization by letting anyone participate. Okay. Dynamic balancing adjustment. The dynamic adjustment part means the system constantly checks the network and it tweaks the rules. Okay. It makes sure the complexity, difficulty, the high privacy blockchain match the current power and the hardware. It adjusts balancing between the two types of the blocks where the network is saying more standard and transaction or more private. TFH-based transactions this balance privacy hidden fairness, okay, working simultaneously parallel generation. If a high privacy block is taking long to calculate because TFH's lower network doesn't wait. It doesn't wait, okay. What is mean? Any change is a parallel block generation. It allow the slow high privacy block and the fast standard block to create the same time concurrently. Why it matters is a prevent bottleneck. The entire network doesn't have to slow down just because one complex private calculation is taking a while. It keeps the network clicking fast. To check, they use multi-head integration mechanism, which is fancy or saving. They have a checking system, make sure that the simultaneous block are merged and the final order result correct and consistent. With a simple summary, the DDA lets any chain handle the high privacy needs, okay, high privacy block, while still keeping the network fast and open there for everyone. Standard blockchain parallel generations to solve the conflict between demanding privacy and maintaining the centralized and stable blockchain. It's interesting. This is the problem solved they address because of this problem. Yeah, I think for with okay, one more. 3.4. Versa has a multi-stage has module enhancing security and efficiency. Okay, as a critical module within the DDA proof of work framework, Versa has focused on enhancing blockchain security and computational efficiency. Okay, this multi-stage hash computation ensure data integrity and immutability. Okay, providing robust, efficient technical support for the blockchain system. Okay, the block production process in the process has begun with dual hash of the block data and the nonce to generate unique input data, ensuring the integrity and uniqueness of the each block. Subsequent calculation generate core parameters, dynamically adjust computation condition based on the block type, high privacy standard, while DDM mechanism balance privacy and computational power at the global network level. Versa has optimized hash condition within individual block. For high privacy block, more complex computations or additional hash iteration strengthen data confidentiality and security. For standard block, redundant step by minimize to improve efficiency and reduce gas costs. Notably, for SAS multistage has designed enhanced data temper resistant while mitigating risk in the global block production fire due global production failure due to the single computation error. By decomposing and computation process into multiple stages, Versailles offers the high fault tolerance for the overall system. Versailles integrates seamless with the other modules in TFF and TFH event protocol. For instance, its dynamic internal adjustment support high frequency data processing within the DDA framework, while its efficient has structure and language integration, pressure, and the parallel block generation. Yes, of course, we are non-technical. Of course, going to be a bit confused. Jimmy now will explain. The explanation to tell how the Versa has algorithm works alongside the DDA. Versailles was smart security guard. The block, that's analogy, like we have a big box, and then Versailles is the smart security guard. It means guard for this mechanism. Okay, they using the security, initial dual hashing, tailoring the effort, dynamic adjustment inside the block. Okay, it's mean flexible adjustment. Fault tolerance, multi-stage hash, it means they using multiple standard hash, team player, seamless integration. Okay. In summary, it's the highly optimized security process that makes every block is unique. Tailor the required computational effort to the block's privacy need. The builders safeguard against the failure, all the while keep the overworked running fast. It's interesting. So I think it is a problem solved just for the security using double standard hash check using a Versa hash or it's even multi-stage hash module. I mean, like, it's not only once or dual time, two time, dual times, but multi-stage hashing. It's complex things that standardize the security of the any chain. It's really cool. So for the next ecosystem product, I would like to discuss or I would like to deep dive into it in the next video. Thank you everyone. See you